good. So welcome our next three speakers for being with us. And without more introduction, let's start first with Francesca. Francesca Sarri is Director of Technology, R&D and Digital in INI. Not much need to explain about her responsibilities. Being a CTO, then you know what she's doing for INI. And we are very glad to have her with us. So please, go ahead.
Okay, thank you. It's an honor to be with you today. And I wanted to speak, I don't have a presentation to follow. I think that a lot of things has been told today, but I wanted to tell to you how a big corporate changes his engineering or adapt his engineering, research and development and technical services to serve the change that we are facing. A lot of things have been told about the role of oil and gas industry and how oil and gas industry is seen by external, by who sees that oil and gas industry is responsible for what we are facing now in terms of CO2 emissions, etc. But oil and gas industry is also very capable of facing and finding solution. And what we are doing is to adapt our organization in such a way that we don't have to, let's say, invent something new, but we have to rely on our robustness, internal robustness in terms of engineering, of project management, capability of scaling very fast our projects, and the habits of inserting innovation in our oil and gas projects. We know that it's our characteristics, no, from ever to do our projects in an innovative way. We know we were pushed to do drillings even in deep waters, even more deeper, etc., etc., etc. So, and we were capable of doing that during our, let's say, length of the projects. So what we are doing now is exactly repeating what we have seen, we have done in our more than 50 years of existence. INI is almost touching 70 years of existence. So what we think is that our role is very important. And the other thing that has been told today is very clear. There is a portfolio of solutions for going towards a decarbonized future. And some of these solutions as now, like CCUS. Carbon capture and storage is something that we know. It's something that we are capable of doing already today. Of course, there are all the rest of the portfolio, renewables. There are also breakthrough technologies like fusion. So what we are doing in INI, what has been done in INI in 2020 is to do, and we were like first in our category, among the first, but not first, among the first in our categories to put together engineering, research and development, and digital, and also asset integrity. So in a way that we can also insert in our new project what comes out from asset integrity findings. So now in my organization are more than 2,000 people, and we have also this big company, 1,000 people working on engineering, any progetti. This is our owner engineering company. And what we do is really to try to put together research and development and new technology transfer, scale up with engineering, and also with the digital, when digital is useful for de-risking our innovation inside projects. So our organization is really doing that with, let's say, innovation within the classical project for efficiency, for streamlining and making easier the project, but at the same time, we are doing the same for bringing new projects in line. And I'm speaking about all the work that we are doing on fusion, for example. On fusion, INI is very much involved. with the CFS, Commonwealth Fusion System, the spin-off from MIT, and our people are working together with people from CFS itself and from the university. So this is very much a team of putting together capabilities, internal capabilities, very rigorous, project management capabilities for scaling up the activities, of course, with the target of giving decarbonized services and product. So this is very much how we have organized, changed the organization of my company since the last 3 years. And this is the way in which we are looking forward to the future. So a lot of the things that have been told today are, of course, we are working on biorefineries, we are working on CCUS, we are working on renewables, on floating wind. So all the portfolio that have been mentioned today is in our day-by-day work. Another thing that was told today is very interesting. It is about the LCA, life cycle assessment. So we believe that also life cycle assessment has to be kept into consideration during the engineering work. And for that reason, we have also built a department who is doing a life cycle assessment of the whole project inside engineering, inside the engineering department. So a lot of the things that has been told today are already, let's say, deployed within the organization and already used to reach concrete results. For example, I don't know, some of the biorefineries that we have converted in the last year have gone through this process, exactly with this philosophy, like the biorefinery that we have converted in Venezia, for example. That one was built converted in 21 months using exactly this concept and these internal tools. Okay, this is my very short speech. But it's what we do. So.
Okay, thank you very much. It's an interesting discussion about the cultural changes that are required in a company, in an organization, in order to drive this type of profound changes that we are undergoing. So thank you for your contribution. It's now the time to speak about carbon capture, use and storage, which is one of the key pillars of the energy transition and decarbonization. And for that, we have two speakers. We are going to have first Dr. Marie Visvein. I don't know if I did it well in Norwegian, but she's Chief Marketing Developer in Sintef Energy in Norway, and also you are dealing with the coordination of the ERA joint program on CCS at European level. So the floor is yours for speaking us about carbon capture and storage.
Thank you. And thank you very much for the invitation to come here. I'm really thrilled to be here in this beautiful city for the first time, actually. And this very interesting day and conference. So I think I have some slides. So this one, yeah. I have named my intervention the following: CCUS as a building block for climate neutrality and transformation of the oil and gas sector. So the outline of my speech is the following. I strongly believe, and if you do the math, it's easy to see that CCUS is crucial in the energy transition. And at the same time, I really like talking about what the CCUS system might look like, because I experience that there is a lot of lack of, let's say, fundamental understanding of the complexity of those systems. I will say a few words about the fact that CCUS is a solution both for hard-to-abate industries, and I would also claim for many parts or some parts of the oil and gas businesses. I will also get into a little bit on the status on strategic work in Europe, including CO2 infrastructure. And I will actually point to a very concrete summit that we organized in Düsseldorf last week called the Green Shift Summit. I think we all have seen those graphs pointing towards the need to both reduce CO2 and to remove CO2. Not spending too much time on that, but to just have it in as a kind of a flash in the back of our heads, I think is useful. Because it's very often that people, they don't like CCUS because it's not new enough. It's like cleaning up the mess from the party, or it's about prolonging the oil and gas era, all these things. And a lot of that is what I would claim is about feelings and not about facts. So if you look into the numbers, and both the IEA and the EU, for example, stress the importance of CCUS to achieve the net zero targets. I would say there is no doubt about it. And I will also say that it's important for Europe to prioritize it, both to reach the climate targets, but also to support the growth of the hydrogen economy that was discussed. As it unlocks the potential for large volumes of low carbon hydrogen in the very near term. And I would also point to the fact that, and the role it might have related to critical materials, as it is not sensitive, I would say, to the global situation related to that. So that's an aspect that is not very often talked about. I will not spend too much time on this, but it's to illustrate the complexity, as I said, for a CCUS system. And there is no such thing as a CCUS system. It illustrates that you could use waste from your forest to produce bio-CCS. It illustrates that you could have a chain ranging with using fossil fuel, producing, having a low carbon industrial cluster with carbon capture and storage. You could need ships to transport part of your CO2, and then you would very often need an offshore CO2 injection facility. Just thinking about that, so many engineering technologies and so much different, let's say, expertise that is needed together in this chain. That is something that is, we as engineers, we should embrace that and see that. And it's a complex thing. It takes a lot of engineering expertise, but coming together and solving this as this very complex chain it constitutes. And this is another way to kind of illustrate that. It's taken from our Norwegian CCS Research Center, NCCS, and it illustrates in this blue kind of circles. We have the kind of the main topics in which we have the research focus in this 8-year national program focusing on CCS research. And again, this illustrates, for example, if you go to CO2 capture, you would definitely need chemical engineers working on solvent technologies, for example. Focusing on the transport and the value chains, you will need physical metering and thermodynamics expertise. Going to the CO2 storage, definitely you will need geologists, and you would need people working on law and communication and so on and so forth. So it's not easy, but it's all those parts are important to get to deployment. This is to illustrate that maybe beyond my topic today, but it's to illustrate also solutions for carbon dioxide removal, CDR, and more traditional carbon capture and storage. So it's to illustrate that there is actually a wide palette and variety of solutions, both nature-based solutions and technology solutions that one could deploy to capture CO2. We all know this, but it's always useful to have it at the back of our heads when we are to discuss how to move forward. When talking about why CCUS, that's a question one often gets. And I think it's important for European industry. For many of them, like cement, steel, waste-to-energy, pulp and paper, refineries, and I will also claim transport, part of that, really need it. It's also, I would say, a business opportunity. It's not very often you hear it, but to store the CO2, it's waste handling. So setting up business cases is also about having business around the CO2 storage. And obviously, hydrogen can be produced from natural gas. And I would say it's important also in reducing the risk of the green transition in Europe. I mean, we heard before lunch about solutions to, I don't remember exactly, but sometimes we get in a discussion about rare materials and what to do if you don't have the rare materials and more electrolyzers. And sometimes it's actually about seeing that we need a solution like CCUS instead of kind of looking for more rare materials or looking for stuff that is already very complex value chains. Yes, and the only way to achieve negative emissions, I think I said that. So over to a few topics on status in Europe. Starting with mentioning that Norway has played a specific role in CCUS. We have been storing 18 million tons of CO2 in the Sleipner project since '96. And I would claim that the next 2 to 3 years are crucial. From 2025, a Norwegian Longship full chain project will be in operation. And in the Netherlands, we have the Aramis project's court approval that clears the path for the Porthos project's realization. Then, on policy, I would especially point to the Net Zero Industry Act first, and then also say a few words about the upcoming industrial carbon management strategy that is in the process. I guess you know, and there are still discussions, of course, on finalizing this Net Zero Industry Act, but the suggestion, as it stands, is to have some strategic net zero technologies that will be commercially available soon to have specific support schemes. One of those are carbon capture and storage. So that has been discussed, but maybe even more discussed at the moment is related to what to do about CO2 injection capacity targets. So there is a so-called Act 18 in this Net Zero Industry Act that claims that put take back obligation on oil and gas producers. That is, I would be very happy to hear comments from the audience on this and how you see how that could solve issues for the industry and move things forward. Coming to a close, this is to illustrate the role of Northwest Europe in the development of CO2 infrastructure. The last 1 to 3 years, the interest and the work on developing CO2 infrastructure has exploded, I would say. It's become something real that the industry talks about, and countries are developing bilateral agreements, and companies are developing bilateral agreements, because you cannot have CCUS without some kind of well-developed CO2 infrastructure. So this is my final one. So taking that, I mean, the fact that Northwest Europe is very special in this. SINTEF, we gathered representatives from business, governments, civil society, and research communities in Germany, the Netherlands, Belgium, Denmark, and Norway. and focus to identify next steps for CCUS and hydrogen enabled by CCS, and discussing what are the hurdles and what to do. And the business stakeholders, they presented the whole entire value chain from hard-to-abate industries with a need to capture CO2 and transport and storage providers eager to realize such services. And I would just like to mention finally that we are developing recommendations based on this successful event, and we expect those recommendations to be launched with a press release on September 28th. So thank you.
Okay, so it's time for our last speaker. Vicente Cortés is co-founder and president of INERCO, engineering company, and also I can mention that he's been professor of chemical engineering at the School of Engineering of Sevilla for many years. So, Vicente, the floor is yours.
Okay, thank you. Well, no, it's okay. Thank you. First of all, thanks for the opportunity to contribute to this annual conference. The purpose of my presentation is to exactly replicate the title of the conference. We have two main words, challenges and engineering. So I'm dealing with the challenges associated to carbon capture and use, and will outline which engineering solutions can be depicted to solve them. But previously, some, let's say, general approach, a general framework. This is a conceptual approach for capture and use, where the CO2 can come either from fossil with cut-off dates in the near future, either air or biogenic. I concentrate on the production of commercial products. I'm not dealing with non-commercial products because the business case is unclear for me today. Those upcoming commercial products are, let's say, molecules which have been used for dozens of years. Methanol, particularly methane and fuels. I will probably concentrate on methanol because there are some upcoming regulations on e-fuels which will probably complicate the scenario for this alternative. But in this case, what we have is the combination of hydrogen and CO2 to produce particularly, methanol. And with methanol, we have the stepping stone, the cornerstone for a new carbochemistry. Earlier, some of my colleagues in the panel have mentioned MTO, and I will mention also MTA, two aromatics and olefins. The landscape in which those challenges I will describe in a minute have to be solved is certainly fuzzy and complicated because regulations take too long to take place, they are not technology neutral, and sometimes the business case cannot be reached because uncompetitiveness of the solutions, and most importantly from the engineering point of view, TRLs of the processes which are required are pretty low in most cases. This approach, the front-end loading, is a common approach in engineering of new processes, new plants. But in this particular case, it's relevant because step one with the assessment of the opportunity is essential to allocate resources. So I want to stress out that F1 and 2 are absolutely necessary in this scenario. And now coming to the challenges. I have identified 6 challenges, very briefly. First, source of CO2. We have 2 alternatives, one producer, one off-taker. Simpler as far as quantity and quality, but interdependency between both processes. Second option, a hub. But you have a hub, the quality and quantity assurance is more complicated, you need a system operator, but on the contrary, you have, of course, assurance that you will have CO2 for any operation of the plant. Second challenge is modularity of the hydrogen production, coming from electrolyzers. This is interesting because it simplifies phasing of investment out of the capacity of the plant. But on the contrary, outflows you can obtain of hydrogen to feed the conversion processes are low compared with the, in principle, unlimited amount of syngas from fossil origin. This is why methanol plants in the lower part of the slide has to be downsized, because it's impossible to feed plants, commercial plants of thousands of tons per day with hydrogen from electrolysis. Third challenge is that you are facing intermittent electricity supply, and of course hydrogen intermittency, with the continuous operation of plants producing methanol. So in this case, the solution could be either or both energy storage or hydrogen storage, which means higher capex in the end of the day. This is why those processes, which incorporate chemical processes, catalysis and separation processes, has to be redesigned, reconceived to accommodate to this solution, because the electricity from the grid is not a solution because of the requirements I mentioned in a minute about carbon footprint for the product. The carbon footprint of the products have to comply with a very stringent demand. I mean, the figure is 28 kilograms of CO2 per megajoule of the product. At the end of the day, that means that the carbon footprint of the energy you use for the whole chain has been reduced as much as possible. That means three solutions, mainly. One is electrification, if possible. Second is combination of exothermic and endothermic processes. And finally, the solutions that can enhance the thermal value of residual heat, either ORCs or other solutions like heat pumps. Challenge 5 is a mixture of environmental and engineering. The DNSH, I mean the do not significant harm criteria, has to be fulfilled by each and every project requesting financial support from either the European Commission or either the financial green funds. That means that on a day-by-day basis, the engineering team has to be in contact with the environmental team, because it's not valid wait until the end of the design process to check if it complies or not, because if not, come back to the starting point. And just to end, challenge number 6, I have divided in two, is the contribution of engineering to increase the TRL level of certain technologies. First, those that are at medium level to commercial one, and perhaps the best example is the solid oxide electrolytic cells, which can accept simultaneously CO2 and hydrogen, thus producing directly syngas, thus avoiding the reverse water gas shift reactor, which operates at 900 degrees C, difficult to electrify. So this is a very interesting approach, but a substantial engineering work has to be performed. And finally, this is my last but one slide. This is a very attractive, innovative way. I have pathway 1 plus 2, from photons, I mean from sunlight to electricity to electrons, and then to electrons to molecules, pathway 2. The approach is substituting that pathway 2 not by conventional processes, but for electrochemical processes. This is a very interesting approach, of course, very far away from being commercial. But the pathway number 3 is groundbreaking, because it's what is called sunlight to X, directly using sunlight to produce molecules. This is far away from commercialization, but the substantial engineering work can help this to be a reality. Just to end, my conclusion is that engineering is quite pivotal in reaching the objectives of the European Union in sustainable energy supplies. Thank you very much.
Thank you, Vicente. The conclusion could be applied to every speech from our speakers. We ended with the conclusion that engineering is pivotal, is critical in order to succeed in the energy transition. We are going to start with the Q&A. Maybe before I can take the question or interest of Marie that was speaking about or was asking what is the reaction of the oil and gas industry. I'm pretty sure that Francesca and Nicolas would like to add also. This new, let's say, draft rule that says that maybe the oil and gas sector should be obliged to store CO2. I believe that the oil and gas sector would be willing very much to put their knowledge, their capabilities to provide CCS or whatever services are done. Now the point is how you implement that, because we have the capabilities, there is a value chain over there. We would like to capture that element of the value chain. Now the point is how regulation reacts to that and promote that. You can use, as we have heard from others, you can use the stick or the carrot. You can use the stick and say, okay, the oil and gas bad guys, they are obliged to do that, and no incentive to do it. What is how we are going to get the value out of a service that we are going to provide? It could be easily done. We could get the credits of the CO2 to compensate for our emissions, whatever. Or you can get fiscal credits, or you can make the emitters to pay for the service. We don't still know which is going to be the approach of the European authorities, how this obligation between brackets will be implemented. But definitely we would like to be positive. We would like to participate in that value chain.
You told everything.
Yeah.
So we don't have to express a preference. We are capable. We have the technologies, of course, but there is no, let's say, I don't think even there is no. The microphone. Oh, sorry. I did not realize. So I go to with the answer from my side. So I think there is no something has to happen. We are, I think, ready to face it with competencies and with our experience, our presence on the territory. Of course, these have to be made possible in terms of permitting and economical scheme, because then you can do it in economical way. You can do it finding the right asset in your value chain, because the value chain is different every territory where you make and every emitters you face. But I think that it's the role of the governments and the European Commission, the local government, to find a way to make it possible. And we have technologies and capabilities to do it.
Okay, so Vicente and maybe Marie, just to close.
Okay. Yes, talking about the stick you mentioned before, the Net Zero Industry Act, as presented, and now it seems going to be changed in this particular aspect, pointed out that oil and gas companies in Europe has to indicate how much capacity of CO2 storage could put in place for a precise date within 3 months after the approval. I mean, it seems going to be changed by the Parliament or whatsoever, but in fact, the stick has appeared sometime in the process.
Yeah.
Yes, so I think it's very useful to have this discussion because, as I said, I think due to the fact that this CCUS value chain is so complex, I very often see that emitting industries are kind of standing on one side and kind of seeing or kind of proposing solutions seen from their side, and they are seeing the taxonomy kind of regulations, and they need to capture to kind of survive globally. And I hear from their perspective, it's very difficult to understand why it should be kind of difficult on the other hand. So that's kind of the let's say, the very interesting situation that we have at hand. And I'm really worried that if this kind of gets too polarized, we will not see CCUS happening. And I think that's a lost opportunity for Europe.
Yeah, and definitely it should be simpler than than it is today. I mean, it's just a matter of putting the economic signals in the marketplace so private investment flows to CCS projects. In the States, they have done it very, very easily. $85 per ton of CO2 is a fiscal credit you get when you invest in CCS. That's it. So in Europe, it's more complicated because fiscal incentives requires unanimity of 27 member states. But okay, they can think on something, but the price signal should be in the marketplace in order things to happen. So questions, please, from the audience?
Yes, thank you very much. The chairman was talking at the beginning about the Antonio Guterres and Fatih Birol, and say that Fatih Birol is very pessimistic, that Antonio Guterres just said that we have opened the door of hell. Well, the words that I have here today has been complex. You say the word complex many times. Challenges, you have said the word challenges many times. And so, what do we engineers have to tell to the citizens about all these complex potential, is another word we have been using a lot, potential solutions when they are seeing every day the increase in the temperature of the earth, the increase of the sea level, there's no water in the Panama Canal. All those things are the things that politicians are looking at, are seeing from the citizens. What do we engineers, not companies, we are not companies. We don't have a P&L account. We have a soul as well. So what do we engineers can tell to the people that see that the Paris Agreement is not going to happen? What do we engineers can tell to the citizens and to the politicians? Thank you.
Well, if I may say something very, very brief. I believe we as engineers, we are here, most of us are engineers. I believe we should convey a positive and realistic message. The climate change can be addressed. There are technological and engineering solutions for that. This will imply that the cost of energy, and we need to tell that very realistically to the citizen, that at the end of the day, or the citizen or the taxpayer is the same way, that we are going to pay more for the energy we need within the next years till technology and engineering contributes that the cost of developing the new products are lowered. This can happen, has happened in the past, and massification, scale up, technology development will help to reduce the cost. But it's a positive and realistic message. What we shouldn't convey is the message that this can be done cheaply. We will not be like that.
But on time, sorry, that's the question. On time, not expensively. On time, can we get there on time?
We need to be optimistic, and we are predicting what should be happening 30 years from now. So if we look at back in 1990, we couldn't imagine which is the technology that today we have in our hands, internet, digital, etc. So it's not just thinking but let's start now. Let's start reducing emissions with the tools we have already at hand, all of them. Not be too prescriptive, not be technology neutral. Technology and engineering will make a good job on reducing emissions. 1.5, I don't know, but we need to react fast. Marie?
I would actually like to refer to a very interesting discussion I had during lunch today, and I would actually like to refer a statement from Professor Ramirez made during lunch. She said the politicians need to understand one thing, and that is these are the goals we need to reach, and these are the tools you have in the toolbox. Because there is so much talk about what would you as a citizen want to see. And as engineers, I think we should contribute to making this choice or this these are the goals and these are the tools to make it more understandable to the public, so that politicians can also convey that message, because it's not about would you like to have, or would you like this, or would you like that, but we need to make the picture clearer and present some very few solutions, so it's not too complex, and to understand that in order to solve climate change and to create jobs, you cannot do anything. You need to have a clear path.
Okay, so now Vicente, and maybe later Eloy would have a question.
Yes, well, I don't want to open the door to the devil, but I fully agree with Luis Cabra concerning that engineering can, of course, reach those targets, because it's the history of engineering from 2 centuries ago. I mean, if electrolysis has to reach higher efficiency than today, it will arrive. If costs will lower, it will arrive, that's for sure. So what we as engineers are capable of is reducing CO2 emissions as much as necessary. What I'm not so sure is that by doing this, we can reverse the climate change, either by no connection between CO2 and climate change, either, or, more importantly, because where is the demonstration that reducing CO2 emissions will stop climate change? And when, taking your answer, when will stop climate change? In 2040, 2055, once net zero is in place, 2060, there's quite an uncertainty. So going back to the positive aspect, engineers can make this happen. I mean, net zero will happen.
Mm-hmm. Very good. Eloy?
Thank you very much. I have a comment or a question I would like to know from you. Vicente has been putting the matter of different alternatives, and particularly referring in some cases to the technology readiness level, no? That has much to do with engineering development. So I would like to know, in terms of engineering, how is your view? And if you can complement that with the idea of cost. It is difficult, particularly on those technologies that are in an early stage, no? But some comment in terms of how the cost of price could really push the technologies ahead, no? And the second is, I am not sure, but in our session and in other topics, really the matter of the Inflation Reduction Act in the United States has been, to a certain extent, a revolution in relation to the Europe approach to some policies for technology and for engineering, no? And I don't know now if in the carbon capture use or carbon capture and storage, the United States really applies also the tools of Inflation Reduction Act to incentivize, and in this respect, if this is so, how do you really see from the panel or from the table the comparison with the things that you are commenting now about this act that I didn't know about? Thank you.
Maybe Vicente and Francesca.
Yes, yes. TRL. Allora, about TRL, our experience, what I see, especially with breakthrough technologies, no? When the TRL is low and you need to speak and to work, for example, with the universities in such a way that changes the way in which the development is seen. You need to push the industrial view. You need to make, for example, we are collaborating with a lot of universities, and we are also working together with the scientists to enhance and make quicker the increase in TRL. How? Working together, opening joint labs, putting our people from industry to work together with the scientists and enhancing that. Then there are tools that can help to doing that. For example, the use of digitalization. We use a lot digitalization for, let's say, making like hybrid simulation, where we use together the model and we make happening parameters to make and risk the development of the technology and simulate the behavior of that technology. So there are plenty of tools that I always speak as an industry because I have seen that is what I experience. So I think the role of the industry in making the TRL, let's say the quickest change in TRLS development is very big. Industry and universities can work together and make it happen in a quicker way. Of course, we cannot forget that technologies to which, let's say, we think to breakthrough technologies, not technology that like fusion or, let's say, SMR, or they will come and they will not be tomorrow morning because they need time to be developed. But of course, you have to work together. And then still comes another subject that it is still a subject of alliances, making alliances between industry and universities, between industries, between contractors and the corporates. So this is something that is happening in these years. I am seeing it happening. I have seen flourishing a lot of framework agreement between contractors and companies for developing certain technologies and make them happen. So it's something that we must be positive and we must work together. This is really my point, because if we work against, nothing will happen. If we work together, things will happen, because capabilities and are there. There are. So things may happen only if all the part of the let's say society work together and not against. This is very much my point.
Okay, so on the IRA, who wants to take the question or starting to take the question?
Yes, I can answer. Okay.
Yeah.
I will take 1 minute for both answers. Okay? 1 minute for your answer. What engineering can do is taking TRL to 9. This is the role. But to cost to be taken down, the learning curve has to take place. So installation had to start, so to replicate units, so the technology vendors may change materials, technologies, coupling, and so on. And concerning IRA, if I understood you well, the situation is that you receive in the USA 80 euros per ton of CO2 you capture and storage. You compare this with your cost for capture and storage, and in most cases, except in cement probably, this is below your cost. So you have a net profit by capturing and storing CO2 in the USA.
And the main problem may be being that in Europe you have to apply for example, innovation fund support, and you will have to wait. In the US, you know that if I kind of comply with these kind of rules, I will get paid. Yeah.
Yeah, the IRA is simpler, it's faster to monetize the incentive. Even if you want to invest because you have the fiscal incentive, so you need benefits and then you deduct your taxes, but you can trade with these fiscal incentives with companies that already have benefits. So it's very flexible, very quick, very fast, and that's why it's mobilizing investments in CCS and in other decarbonization and clean technologies. We need to be, again, a little bit optimistic, but it's going to be hard, that the European authorities understand that the complexity of the legislation, regulation, permitting is a barrier for the decarbonization. My last word on CCS is that on top of, I would say, political willingness and regulation, the social acceptance is key. I mean, there are certain parts of the society that wouldn't like to see CCS too near to their homes and places, etc. But this is also a responsibility of all of us, companies, politicians, to educate people about what can be done and what can be done safely. So there is another question. If there is time, we are very happy to continue.
We have been for the whole day talking about energy, but only at the end, Francesca has mentioned fusion. And she said that ENI is collaborating with MIT in a program. Please, could you elaborate a little more about this? What are you doing about
I can
fusion?
tell something, of course. We, as ENI, we are working on fusion since when MIT spinned off Commonwealth Fusion System, their startup. They started up this small company. It was, I think, 2016, 2018, and we were very, very keen, and we soon collaborated with them. We entered soon in the capital of the startup. Now we are the lead investor, and we are working very hard with them. Together with them, we have our people, secondee inside the startup, because we really believe that fusion is one of the options. Of course, not tomorrow, but it's coming. It's coming, and it is not anymore a matter of academia. It's a matter of technology transfer. It's a matter of industry. Of course, that will need the time, that will need maybe early 2030, there will be a first of a kind with the first attempt to transfer heat and to produce a tritium. We think that the second half of this decade we will have also a first test facility for testing Q larger than 1. And but you know, the world now is moving toward that direction. There is a flourishing of startup and also government initiative on this subject. Like we were counting like more than 130 initiatives around the world about fusion. Around 30 private, others from governments. So it's a time, and we must be positive, and we must work for that.
So thank you very much. And before closing this session, just join me, please, to thank the 6 speakers with a last applause.